So the plan for the course is for 10 days. We are doing a little bit of shift in the planning. Obviously, I was going to be here last day as well, but sir, I have to be in another place. So Professor Muralidhar and Professor Sahajao will take the last 2 days of the course, and we will go before that. And rather than 4 hours a day, we will increase your workload to 5 hours a day. For a very simple reason, when we start the lab work, it takes a bit time for things to mature. So we'll give you more time in the lab, and that way we'll get enough time in the last day to keep things open or for me to go and sleep, right? And sleeping is also a vital activity of being a professor. Either sleep during the lecture or... Now, what language do we speak here? We speak English, right? If you don't understand my English, do stop me there. My English has become a very strange mixture of English, British English, German English, Indian English. Okay? My Telugu was hopeless and it still is hopeless. So I can try, but will not work. Hindi will come from time to time. So if you don't understand anything, do stop me then and there. Actually, by Government of India policy, if I do the entire lecture in Hindi, I might get a prize, something like that. You might not understand any of it. Let's try again. Let's try again from a different port. Okay, just give me from a different port. I might have to restart my machine. It thinks it has taken because it has changed the... Okay, it is connecting and disconnecting. So this is the computer science revenge on electronics people. Our projectors never work in our department. Let's try that thing. So I will transfer it to a USB disk. Those who have got a background in robotics and automation, I'm going to give you a bit of shock. This is not about robotics and automation. The entire course is going to be about things which goes into a robot. So to start with, we somehow have this fascination about humanoid robots, right? Robots which look like us, essentially, which are bipedal, have got 2 hands, and have got a head. I still am trying to understand why do we want to do that, because to be very frank, walking on 2 feet is quite challenging. Walking on 4 feet is nice. Walking on a circular feet is even nice. You can roll anywhere you want. Agreed? But we have this fascination with a humanoid robot, so let's go with a humanoid robot. I'm sure people who work on technology and society can give better answer than I can. Now, if we are trying to make a humanoid head, then we need to, is it on? It is on, okay. Figure out what does a head do. So what does our head do? Thinks, that's a good one. Other than thinking, what does it do? So thinking is processing, right? So it takes that data, and what does it do? What do you mean by thinking? And so we do process the data. What do you do with the data? We try to extract information out of data. Okay? So right now you're looking at me, but you're not just looking at me. You're looking at the screen, you're looking at the projector, you're looking at this whiteboard, you're looking at my shirt. Your brain is ignoring all of this information. Right? Just now when I said look at my shirt, all of you guys looked at my shirt. Till this time, you're not looking at that. So brain had figured out this is a useless information. That board is, the eyes are capturing everything. They're like a camera, right? They're capturing everything. But your brain has filtered out this information. It has learned with due course of time how this is not information. So all of this is data, so it extracts information out of data. And then it does something meaningful with the information, right? If it figured out that there is a lion coming in, the meaningful information would be There's a predator coming towards me, and the action would be run if you can. Or if you become like me, then pray, right? You're not going to beat the lion in running. So that's one thing. What else does the human head does? And Babu, by now you realize I'm a professor. I have infinite patience. I can wait. Motion? Emotions. Still part, okay. To some extent, the question which you might ask, are emotions independent action or they're still part of processing? You look at somebody, oh crap. So the other rule which I saw after entering Warangal was ragging, and the other big board was personal display of affection, PDA. I had to figure out the whole thing to read. Oh, wow, we have got regulations against this. So the question still remains, are emotions independent activity or they are part of processing? You see somebody, you feel good. You see, you look at your son or daughter, that affection is allowed, right? One hopes so. So they are still, or you look at a, thing, something you feel like crying, somebody's dead. I think they're still part of processing. I might be wrong, but okay. So question still remains. Now, you guys are thinking the head to be this. There's more to the head. Head starts from here. So now you tell me, what does my head do? I didn't ask what does my brain does. I asked what does my head do. So tell me, what else does my head do? It controls information, so part of data processing, the second stage of data processing. What does it sense? Good. We start with imaging. We have eyes. We have ears. So two senses. What other sensors we have? Taste. We have some sort of chemical sensor. We have skin, what does skin smell, sense? Now we're talking about physical quantities, right? So we started with vision, which was sensing light. We went to sound, which was sensing audio. We went with chemical sensor on our taste. What does skin sense? All of you guys have got this sensor. Tell me, what does it sense? It's a wonderful sensor. It senses many things. What else does it sense? Temperature. Okay, one thing. What else does it? Surface structure. What else does this? Pressure. Well done. It senses pressure. Somebody beats us. We know that, right? What else does it do? Of all the senses we are going to talk about, this is the most complex one to design, to reverse design. It's not one sensor. It also has hair follicles. So it's time for you to go and figure out what do the hair follicles do. Now, here is a very interesting question we have. So we talked about things which we have, right? Oh, some of you forgot. There's one more sensor which is forgotten. So we looked at tongue, skin, ear, eye. What have you forgotten? Nose. So what kind of sensor is the nose? Kind of a gas sensor. Oh, sorry, a chemical sensor. Right? Smell, well, we think so. So at least if you took at the word of panch indriya, what we called in traditional science, we have at least 5 different sensors in our human head. Then the question comes, now at least these we should be able to sense using a robotic head. If we want a robot to feel and look like us and do things which we do, this much it should be able to capture. Agreed? See, if I make a human head, I have got all these sensors there. The next question to ask, and now I'm going to abuse in the entire computer science department. By now you would have figured out that I love my department and I've been trained by the people here, so what do I do? Where are these sensors located compared to the processor? The processor is the brain. Now, I have got a big sensor called skin which is running throughout my thing. But my sensor, the skin sensor on my toe is not as sensitive as my face. Agreed? I mean, some of you might have a very sensitive toe or leg. But generally speaking, our legs are a bit more hard bound than our face. Agreed? I mean, there are people who will walk bare feet on hot road who are going for Sabarimala and this, but if you put the same heat on the face, it will be felt. Okay? So the good skin, the good sensor, the highly sensitive sensor is here. And as we go away from it, either the sensor is bad or there is too much information, there is long distance for the information to travel. So this is something unique which the human body or most nature does. It keeps its good sensors very close to the processor. Agreed? Now think what we are doing in computer science. We are making these huge data clusters, and the idea is you collect information from mobile phones, different sensors, and we send all of this information to a big data cluster, which then processes this information. This is exactly opposite to what the nature did. Now, we may agree or disagree that nature is a good engineer. Right? I mean, nature is a bad engineer as well. Agreed? I mean, think of this way. It has put an appendix, the whole role of which is to kill me someday by bursting. Okay? And there are sensors which keep on degrading. I mean, many of you are wearing glasses. It's a very good example of degradation of sensor in our lifetime. Okay? But this is very interesting. It keeps all its good sensors close to the processor. So it does not want long distance communication of data. So that's slightly different to the way we are doing deep learning right now, or artificial intelligence. Actually, it's very different to artificial intelligence. So nature did not believe in one central intelligence and everything being a terminal of it. It was not a mainframe computer. It was very much distributed intelligence. Every brain has got an intelligence. I think in something, my colleagues in humanities think in something, my chemical engineering colleagues think in, and we all collectively progress our humanity. Whereas the way we are going in deep learning regime is where there's one big machine, a giant machine, which collects all the data and does interesting thing to extract information. We don't do that way. So that's the first thing which we have to think very carefully. By doing this small distance communication, we are saving quite a lot of things. We are saving a lot of energy. Now, most of you would have done a lecture on communication theory in your undergraduate. And most of you would have slept in the third lecture of communication engineering in undergraduate as well. You know, when the Cloud-Shannon theorem started. Agreed? At least I was hoping one person should say, no, sir, I really love the theoretical communication engineering. The bottom line remains, for any data to move, it needs energy. So while we were evolving, the nature decided that not to move important information for a long distance. Right? So things are going from here, somewhere here, from eyes, somewhere to the back of our head. That's where our primary visual cortex is. Skin information is moving from all over, and as we go away, our sensitivity starts falling down. So we have agreed on that thing. So this goes to show, if we are going to mimic nature, either we put loads of, and you could say, why don't I have an eye on my knee? It's an important question, right? If I had an eye on knee, I could, or why don't I have an eye at the back of my head? I need to turn my head. Think of it this way, mechanical motion is more energy consuming than having another eye at the back of my head. We still don't know why nature did that, but we know what it did. You believe in nature, you believe in God, whichever 20 million gods you believe in, the argument still remains the same. There should have been a logic behind it, unless, of course, you believe nature is illogical. So if we are going to mimic that, we need to get all of those sensors at least and a few more. Now we know nature is not just what we see and perceive, there's more to nature. So we see only visible light, but we know infrared and ultraviolet exist, right? So one would kind of believe that the intelligent robot which we are going to make would also be able to sense these things, right? The other thing which we have as human beings is our sense of anything is not linear. So most of our sensing is either exponential or logarithmic. A very good example would be if the coffee is a little bit hot. Okay, how many are coffee drinkers here? Everyone? It's South India, for heaven's sake. We have to be coffee drinkers, right? I saved lots of money by not drinking tea or coffee in my bachelor's. But if the coffee is a little bit hot, you feel it. If it's very hot, you only feel it's hotter. And the hotter it gets, at one point it will burn your teeth, but our sensation is not linear. Same with our skin. I mean, the example I used to give is if somebody punches you on your face with one force and punches you with slightly more force, the effect will be. And same with eyes. I mean, room is a little bit bright. From dark to bright, you feel it. But the brighter you get, you feel less and less of it. Okay? So it's not a linear sensor. Most of the time, it follows Stevens' power law. Right? It's some power function we have. So that's all right. The other good thing which nature had was it had the third dimension. It could design as a 3D structure. Now, as an engineer, we can design things as 3D structures. Somehow we don't like things in the depth. Our mobile phones have kept on shrinking in size, right? Though I must confess, I never understood why as electronics engineers, we try our level best to make phones very thin. And then our first thing which our customer does is buys these, right? और अगर उससे पेट नहीं भरा तो buy a screen protector as well, a thick one. I mean, tell us in the beginning, we'll make a thick phone. We used to make thick phones. And same with television screens. We used to have thick screens and we want things thinner and thinner. So that's one limitation we have. Now, from microelectronics background, when you're starting making chips, that's other limitation we have. Our chips are not three-dimensional. They are two-dimensional structure. We grow things on a flat surface. Why we do that, we will see a bit later. So now we have this problem is we could need to come up with a chip which not only has the processing part, which was there right in the beginning, but can also do sound, video, or at least one of these. Okay, even if I don't try to make a single chip which matches the human brain, but at least one of these sensors. Agreed? Because only then we will have these chips going into the human head, robotic head, to make a robot out of it. Good. So, and then the next question which we have to ask is how good my sensor should be. Now this is again where we have a bit of a conflict. Because we are designing things to be bought by the market. Okay? If you make the best device in the world, nobody buys, it's useless. At the end of the day, engineers, okay, let me ask this question to you. Name 5 famous scientists which comes to your brain, and I will just pick random people and you have to name a scientist. The person wearing jagged t-shirt here. Einstein, first name, almost always. You can bet on one of these two names which will come the first, right? The lady with a smile, the second person, yes. Yes. Tesla, okay, I was hoping for Newton. But Tesla has come. Fine, we will live with Tesla. And the person with the red shirt. Niels Bohr. And your name was? Madame Curie, okay. Gender equality in action as well. And the lady with the black cloth here. Just sit, don't need to stand. Galileo. Okay, so we have got the 5 famous things. Well done. And all of you are engineering students, right? Next question, name 5 famous engineers. Let's pick the same people. Vishwesvaraya, all Indians go with that name, right? Civil engineer. I could have restricted the question, name 5 electronics, but let's go with 5 engineers. So we get one name, Vishwesvaraya. Second, all those who were quick to name Einstein, Galileo and things. Abdul Kalam, okay, I could give him at least by, both are Indian famed scientists, right? If I ask the same question in Israel, they would have never heard of these people. Agreed? But theek hai, chalo, I will take these two. Third one? Who the hell is he? Sigma AI. New startup, right? A space scientist, and you use the word scientist. I didn't ask for a scientist, I asked for an engineer. Till now you haven't talked to a single engineer whose tools you use. I mean, this, that. This year the guy who invented USB got a Padma Shri award from Intel. You still don't know him or her. Come on. Okay, chalo, I will take Nambi Narayan as a half engineer. Anyone else? And these are the people whom you are naming, except Vishwesvaraya, are our generation people. Like we have known him. From history, you can't name a single engineer. And you all are thinking, kabhi to padha hoga kisi ka naam. So what's wrong? You did engineering, you worked hard to get into engineering. You should have written an entrance exam, right? And then you'd have written another entrance exam to get into masters. Name the fourth engineer. Aryabhat. Okay, the USB guy, right? Half. Okay, chalo, I'll give him one. Again, our generation. What does he or she do? Okay, I must confess I don't know. What, again, does anyone else know this name? So he named Patirappa. Do you people know? Anyone else knows? How many people have heard his or her name? Raise your hand. None. One. Famous engineer. Satish Dhawan is a scientist. Come on. Let's not abuse our clan. Jack Kilby. Finally somebody come up with a proper engineer's name. What did he do? You don't answer that question. Let's ask other people. What does Kilby do? He got a Nobel Prize, by the way. Very few engineers get Nobel Prizes. He got one. What did he or she do? Leda. Why are we not famous? I'm not asking the question, name the famous engineer. I'm asking the next question. Why are engineers not famous? And don't get me wrong, engineers have been famous in their lifetimes. If you ever visit Paris, I will ask you to, everyone goes to see one building in Paris, right? Which is Eiffel Tower. On the base of Eiffel Tower, the first floor, on all sides, they have written the names of famous people of their generation. So at one side, you have the scientist, Ampere, Lavoisier, Fourier. The other side, and this is why I like Eiffel Tower, they have named 20 famous engineers of that time. You know what's the worst part? I couldn't understand the name of any one of them. So why don't engineers become famous in history books? We made very important thing. You're standing in a building. Somebody discovered the idea of how to make a building. Somebody came up with the idea of Portland cement. You're using a mobile phone, communication. Do you think this happened just out of thin air? So I have a theory. I might be wrong. The reason why we are not famous is because we make money. Most of our products make money in our lifetime, and money and famous thing don't have a correlation with one another. Okay? Which brings us to the old thing, whatever we make has to make money in the market. So it has to have certain specification which the market can understand. All right? And this will become very important when we start picking up the next slides. Because we might come back and say, here is the best camera in the work. Market will still not buy it till you convince it to. There's a quiz which I was going to do in my next lecture, but let's do it now because this is a very important thing. All of you have cameras? Anybody without a camera these days? Yes, no? All of you are just looking at me saying, kya fark padta hai? The world is going to come to an end anyway. Why should I answer this professor's question? All of you have cameras, right? How many megapixels? 38, one number? 48. Ah, okay. So, no, sir, not that low. Huh? I've got a good phone. So, 48 megapixel. What other numbers we have? 16 or 60? Sorry? 16, 16 megapixel. 53 megapixel. Well, that's a strange number to have, but okay. Anything? How much? 200 megapixels. Somebody got a phone in his dowry. (200 megapixel). Good. Anything else? 10 megapixel. Fine. And you have looked at, most of your phones would have multiple cameras now, right? Mine is a bit older, so I have 2 here and 1 in front. Some of you have my 4. My prediction is in 10 years, we'll just have cameras in the whole background, right? I have got 40 by 20 arrays of camera on my phone. So all of you are engineers, right? Which brings me to the next question. How many megapixels do you need? So all of you answered this question, how many you have, how much do you need? It's not a dharmic question. It's not a Kumbh Mela question, right? That's a good question. That's a very good question. Because if you ask that question, then you will answer the question, how many do you need? So let's ask the question. Need for what? What do we use our cameras for? And camera is a sensor I'm going to spend a lot of time. I did my PhD in that field, by the way. Okay? So we're going to spend a lot of, we're going to make a camera for heaven's sake. If we are lucky, we'll make an image sensor in Cadence. Okay? So, and this is why I'm asking this important, because I could just tell you, this is the sensitivity we need, this is the intensity we need, this is the frequency of converge rate we need. I don't want to go through that. I want you to raise the question by yourself. This is what we need. So what do we use cameras for? Capturing images. Good. What do you do with those images? Because first I'm going to capture an image, which means I need certain specification of the image, right? Record data, okay. But no, I didn't ask you to. I asked, what do you do with that images? आप क्या करते हैं? Memories. When was the first time you got a phone? In year 8th, right? Give me a year. I'm asking to you. Which year was the first time you got a camera or camera phone? And if anybody thinks the question which I am asking you is a bit more private, stop me then and there. Okay? Just say that, I got the phone in my dowry, sir. I cannot answer that question because there's Anti-Dowry Act in India. That's perfectly fine, okay? Remember, I come from Arunachal Pradesh, where men have to give dowry to women, okay? So we are equal opportunity abusers of Indian law. So 2008, so 16 years ago, you got a camera phone, right? You got 2016. Let's take the number. 8 years ago, you got a camera phone. So you have been taking pictures from 8 years? Do you remember the picture which you took on 13th of January 2009? It was Makar Sankranti or Bihu or Ugadi Day. Ugadi 2009 was Pongal Day, right? Yeah? I'm sure you have taken a picture that day. You have no idea. Do you remember where it is? In your phone somewhere it is, right? Or you have transferred the phone to a Google data space somewhere, right? If I ask the same question to any one of you, what have you done with your images? The answer would be nothing. It's stored somewhere. You answer the question right, for memories. We all think this will be in our memory. Now, my father's generation had the 35 millimeter camera phone, right? So one reel will give you 35 pictures. So on their wedding day, they had this exactly 35 photos, and they know which photo has which one in it. right? Or my early childhood. I have 20 photos of my early childhood. Half of them are me looking like because you're not ready for so you could not revise. There was no Photoshop, but you knew exactly what that photo is. You guys have 2,000 photos or 100 photos, at least 20 photos a day. You have no idea about it. Am I wrong? So question still comes, what do you do with the images? So memory is one question I have ridiculed right now. It's not going to work. Maybe when you become 60 or 80 and you go through your stash of 1 million photographs, you at least take one photo a day, right? 365 in a year? More? 500 in a year? You live for at least 40 or 50 years of your camera picture taking. So that's 25,000 photos minimum. And this I'm talking about people who use less phones. If you go to a wedding, 200 goes in a day. Right? Or birthday party, or you reach some nice pictorial places, rather than looking at the lake, you start taking picture of your lake. And then you turn around and take your own picture of the lake. I think you should know I was there. But anyway. So memories are not a right answer. So then again the question comes, what do we do with the images? Have we? Have we extracted any information from our pictures 10 years ago? No, we haven't. Framing a video. I haven't come to video yet, sir. That's my next question. I'm still at still images. I'm coming to video, don't worry. We're not too far. Well done. That's one answer which I have got, which is very correct. You send it to your friends to see. First thing you do, but first thing which you do with an image is look at it yourself. Agreed? Either on a phone or on a computer screen. Yes, no? So an image should be big enough to be displayed on my screen. Now you know what's the next question coming. What's the resolution of your computer's or of your monitor screen here? All of you have got mobile phones, right? What's the resolution? How many pixels does it have? And Babu, your homework for all the boys and girls is whatever electronics you have in your home, you need to know its specifications tomorrow. Or else you will do the 10 push-up routine here as well. Or running in the round, or you'll have to sing a song, one of the options. I don't care if I don't get another Gyan or Spark course ever in my life. And I'm known, as long as I don't abuse certain individuals, my visa will not be cancelled to this country. Okay? So you should know what, and you are electronics people, you are engineers. We should know what we are having. I mean, we know the shirt sizes. Okay, mine keeps on increasing every few years, but we know that. So now do a Google search on your own phone and tell me what's the resolution of your screen. And those of you who are not doing it will get the question from me, don't worry. Phone screen pucha, laptop screen nahi hai. Huh? You do remember I'm the old school professor here. Answer the question which are asked. So you have a mobile phone with you right now. You should be able to figure out its brand by going into settings, about, and then you should be able to do a Google search. What's the resolution of my screen? That's a very important question which I'm asking, because we have just realized the first thing we do with an image is we look on the screen. Most of the time we are looking on a computer's mobile phone screen. Sorry? I get a number? 2340 cross 1080. Give me, so do that multiplication. Or else I have to do it on the whiteboard. And these days I'm teaching my young son, so I'm very good in doing 4-digit multiplication. Yes? 9,21,000. 921,000. Good. So one person has 921,000 pixels. Another number? 25,90,000 pixels. So 25 lakh is 2.5 megapixels. Right? Another number? How do you have got 25 lakh? What screen have you got? This looks like one of the fancy screens Samsung executives carry. What's the resolution? What's the resolution, X versus Y? So 2400 10 to the power 3 into 20. Yeah, okay, yeah, sorry. No. It can't be 25 lakhs, is it? 2.5 megapixel. No, yeah, 25 lakhs, yeah, sorry. I'm converting from mega to lakh. Okay, guys, engineers. Go in 10 to the power X units, okay? Mega kilo, not lakhs and crores. So 2.5 into 10 to the power 6, okay? Right? And I had 971 kilopixels there. So 2.5 megapixel, somebody else said 2.5 megapixels. Sorry, madam? Ooh, now she has got a good phone, 4.3 megapixel. Well done. Whom did you abuse to get your phone? Was it blackmailing your father to get that? I will not study masters till you give me a fancy phone. Well done. If you can get that, be my guest. And Europe often says, make a girlfriend or boyfriend from humanities department. Their phone or computer will stop working someday. They will bring it to you fixed, and that's how you learn what's the inside of a computer. If you can fix it, the relationship continues. If you can't fix it, it breaks, but at least you have learned about computers. So, very interesting story. 4.3 megapixel is the highest number which I got from a lady, and that was in minority. Most of you have around 2.5 megapixel. And you are taking a picture which is 200 megapixel or 60 megapixel to display on a screen which can only do 4.3 megapixel. Kuch to gadbad hai. Isn't it? So essentially, we are taking a picture which has higher resolution than what we can see. Of course, you will say, but sir, I can zoom in and I could figure out who was the person standing behind me. Okay? But you don't do zoom in most of the times. First question. Second question. So that was a dilemma we have, right? Our screen cannot display the images which we are taking. Good. So fine. Okay, sir, that's not the only screen we work on. We also have computer monitors, which are big. What's the resolution of computer monitors? Another Google search. I should not be giving you all the gyan, right? You have Google. You should be able to figure that out by yourself. 1920 across 2048 is one number somebody is throwing at me. 4K is some number thrown at me. Which is 4K? This is not 4K. I should make some of you stand there and look at the specification of this projector. No, we can't do. None of you are tall enough to reach till there. I think the tallest person here has been Muralidhar sir, and I can't make him do any work. So even your computer screens don't have that high resolution. So we found two applications of the images which we take. Either we see them or we send it to somebody on social media. And the social media people are also looking at the image on the same screen, mobile phone or your handheld. So why the hell are you having 200 megapixel? Well, dowry is an answer, don't get me wrong. When you're taking the Dahej, which is highly illegal in this country, higher is the better. Now the reverse question. You also take selfies, right? What's the resolution of this camera, the front camera? 14 megapixel. 5 megapixels is another number which I'm getting. Now things are becoming interesting. 10 megapixel, but this is significantly smaller than our back camera, right? And we do take a large number of selfies. And selfies images are not that bad, is it? When you take your selfie, is the image quality much worse compared to when you take this? Not really. The image quality is worse. If it's 60 megapixel versus 5 megapixel, it has to be worse. Why don't we see it worse? When you zoom, essentially for your own screen, it doesn't matter. And now all of you are going home. Next phone, 5 megapixel back camera. So why do we have 50 megapixels? None of you are professional photographers. Is anybody who's a professional photographer here? I'm a semi-professional, but I would be the closest to which comes to this. So why are you having 50 megapixels? You don't even have a good lens. You don't have space to make good lens. As you know, electronics engineers move very fast. We keep on making more pixels. Our colleagues in physics department, whom we gave the task to make lens, they are slow movers, right? Every 200 years, one major discovery. So Apple fell down, nothing has fallen since that time. So why do we have 50 megapixels? Do you? Do you capture more information is the question which I am asking. You can capture, I agree. But actually to capture more information, you would need a good lens. Have you seen those sports cameras with massive lenses? They capture a huge information, right? They have got a good lens assembly. We don't have good lens assembly. We can't have. We're not going to have a phone which is this big. It's not happening, right? It will not fit my trousers. So why do we have 50 megapixel? Well, I used to give my second lecture, it used to be, when will we get a gazillion megapixel? You know, more and more is better. I'll give you the answer to it right now. We have that many for a very simple reason. It's called the market. Most of my customers have no idea about image quality, lens resolution, illumination intensity, all these technical terms. Hey, most of my engineering students have no idea about it. Had I asked you what's the quantum efficiency of your pixel, you'd be like, what the hell is quantum efficiency? Agreed? The only specification you know of your camera is number of pixels. And that's the only reason I asked you that. Fill factor of your pixels? Range of intensities it can capture? Nah. But you do know I have got 200 megapixel, which is more than 50 megapixel. So market decided, and because exactly if I ask you how many megapixels do you need, you'll only need 3.2 megapixel. Because the worst thing which you do with an image is not to look on your screen. 2.5 megapixel is what we figured out was the average screen. The worst thing which you do is print. That's where you need dots per inches. Remember, the printed image is bigger. And the largest you will ever print will be that postcard size or an A4 size. These days you don't even print that many. Now that process is abusive to image. It needs more what we call as dots per inches, DPI. So there you need more pixels. So if that's the worst you are going to do with your image, 3.2 is good enough. And this is why we had a generation of digital cameras with 3.2 megapixel, or 5 megapixel is good enough for this thing. And this is why your front cameras are very much static at 5 megapixel range. For things which you are going to do, that's good enough. But we still sell 50 megapixels to our customer. Right. So what technology can say this is good enough for you? I mean, we need only 6 shirts, right? Maximum. 1 for each day on Sunday for washing. So I ask my boys, how many shirts do you have? The person with the red shirt. 5. Oh, there's a gentleman in the room. I shouldn't even ask this question to my female students, right? I'll be killed. And of course, I should never ask this question to my wife. That will be the end of civilization. Particularly when we are in India to also attend a couple of weddings. And if that's the season, then that question should never be asked. So we're talking about the specifications of our sensor. We are going to find all specifications of the sensor in exactly the same way we did it. So first specification we talked about is resolution, the number of pixels we need. Okay? So one thing is technical needs, other thing is a marketing need. So market decided that my customers are happy to pay for a better phone, or let me correct it. My customers are happy to pay for a camera with more megapixels because that's what they think is better. All of us learned number system in a school. 100 is better than 50. So they're willing to pay for it. If they're willing to pay for it, hell, we will sell poison to our customers. We are engineers. We do sell poison to our customers, right? Don't we? One person is saying, yes, sir. Poison, nicely graded, made in, Intel labeled poison would be good enough. Okay, let's ask an ethical question, because we're also going to do a lot of AI in next 4 days. So let's think, this is an example which I'm not taking from my work. I'm taking from another famous person, but I kind of hope you have not heard of this example. So let's think I make a product, okay, which everybody in the world will have to use, will use it. You'll bring it to a market, right? Let's put a substitute. It will kill 20,000 people every year. Now, will you bring that product to market? Yes or no? I just need yes or no answer. So the question is this. I make a new product which everybody in the world will use. You cannot not use this product unless you live in Forest of Andaman or a rare place. You have to use this product. Okay? So everybody is going to be a customer. I can be a billionaire or a trillionaire. But the product will kill 20,000, at least 20,000, if not 200,000 people every year. So all those who will still bring the product in market, raise your hand. 1, 2 persons. All those who will never bring the product in your market, raise your hand. All the girls? No, we are not going to kill the people. And the people in the back are, when is lunch starting, right? Or you are like, sir, as long as the package is good in that company, we'll bring the product. Right? Campus placement hona chahiye. But majority still said they will not bring the product to the market. Let me give you an saying that this product exists in the market. Have you heard of something called automobiles? Cars, buses, trains, planes? Everyone uses them? Just by sheer accident, they killed that many people. I mean, 20,000 would be the Indian number. Global number would be much higher. And then they cause pollution and everything. That I'm not even talking about pollution. Yes?
In India, almost 1.5 lakh people every year get killed by car accidents or any accident on the road.
So I should have gone for 150,000 number. And maybe that would have made even those 2 people who were willing to kill 20,000 people turn their hearts. Now, this may not be our problem as engineers, because we never think about the end goals of our product. I mean, heck, we are not even thinking what will happen to this mobile phone 5 years down the line. All of you are buying one every 3 years, 4 years? Or Apple and Google forces you to buy a new one because the software update does not work? What happens to these when you give up? They go in landfill somewhere. For all the talk